Okay, Unit 5 review. Just scroll up the top. I'm going to go over 2 rounds and you got 10 problems doing the assignment. Write an equation for that table. Okay, so number 1. I'm going to call it example 1. Okay, write an equation for the table. Okay, so we have months defined by the variable M, subscribers defined by the variable S. So the months go from 0 to 4, 6, 48, 56, 64, 72. So S equals, starts at 48 and then it's adding. Okay. Now, then what we do is we start subtracting. 72 minus 64 is 8. 8, 8. So I go, okay, first, before I did that 8, I should have went blank, M. Then we have a ratio, 8, and then that's 2, 2, 2. 8 to 2. Now, 8 divided by 2 is 4, so if that divides and you don't get a decimal, write it as 48 plus 4m. Okay, try not, only leave it as a ratio if it's a decimal. Okay, example 2. Tell whether the function is linear or non-linear. Okay, so we got our XY table, and it goes 0, 1, 2, 3, and then we have 2, 5, negative 6, 4. Okay, so if I take a calculator and go 4 minus negative 6, that's a change of 10. If I go negative 6 minus 5, okay, that's different already, so that's non-linear. Okay, example 3, I'm doing the same thing. Okay, so 0, 1, 2, 3, 7, 4, 1, negative 2. Okay, so negative 2 minus 1, then 1 minus 4, and 4 minus 7. I got negative 3 every time, so it's linear. Okay, then to the graph paper we go. Graph the function y equals 2x plus 1. So you got to go to a piece of graph paper and just write that out. This is example 4. Just write that down. So to graph this, we make an xy table, 2, negative 2, negative 1, 0, 1, 2. And then y is equal to 2 times x plus 1. So 2 times x plus 1, 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 2 times x plus 1. So I put negative 2 over the x, and then we take 2 times negative 2 plus 1, negative 3. Okay, put negative 1 in for x. 2 times negative 1 plus 1 is negative 1. 2 times 0 is 0 plus 1 is 1. 2 times 1 plus 1 is 3. And 2 times 2 plus 1 is 5. Okay, now I graph them. So x runs from negative 2 to 2. 0, 1, 2, negative 1, negative 2. Now put a 0 right on that y line. And then we have to go up to 5. So 1, 2, 3, 4, 5. But we also have to go down to negative 3. Negative 1, negative 2, negative 3. So negative 2, negative 3. So negative 2 on x, negative 3 on y. X is negative 1, y is negative 1. So negative 1, negative 1. 0, 1. So stay in the middle and go up 1, 1, 3. So I go 1, 3. 2, 5. So I go forward 2, up 5, and that's my line. Okay, now on number 5 and 6, you're going to have to, example 5 and 6 is example 5. You're just going to have to, we'll look on the camera. Vertical line test, tell whether it's a function. Okay, the graph is needed, so if I make a vertical line, I go through 2 points there, so it's not a function. Number 6 is the example 6 is the same way. That'd be 1, 1, 1, 1, 1, 1, 1, 1. That's a function. Okay, now I'm going to continue on scratch paper. Done needing the graph. Okay, identify the domain and range of each relation. Tell whether the relation is a function. Alright, so we have 0 with 0, 1 with 4, 2 with 7, this is example 7, and 1 with 6. So the domain and range are easy to figure out. Okay? X, Y, X, Y, X, Y, X, Y. So 0, 1, 2, 1. And then the range 0, 4, 7, 6. Okay, I have repeats of 1 in the domain, so therefore it's not a function. Okay, next one. Example 8. Negative 2 with 4, negative 1 with 1, 0 with 0, 1 with 1, 2 with 4. Okay, so the domain and range. So domain, negative 2, negative 1, 0, 1, 2. The range 4, 1, 0, 1, and 4. Now, I don't care if we have repeats in the range, it's all about the domain. There's no repeats in the domain, so we have a function. So there's a domain and range, there's the function. Okay, example 9. I have 512 megabytes M of memory on my computer. That amount decreases by 3 megabytes per photo I upload. Write a function rule for the situation. So I go M equals, we have 512, then we decrease by 3, but it's per photo, so it's times P. Okay, that's the answer. And then number 10. I make $25 per hour at my job. My boss has a limit of 35 hours for each employee. What is the domain range of the situation? Is the graph continuous or is it? Okay, so example 10. So we got to find the domain and the range, and then we have to ask ourselves if it's continuous or discrete. Okay, so I want to make a table, okay, an XY table. I have hours and dollars highlighted. Hours is the X, dollars is the Y, so 0, 1, 2, 3. Now, if I don't work any hours, I'm not going to make any money. If I work 1 hour, I make $25, because 1 times 25 is 25. Now, 2 times 25 is 50. 3 times 25 is 75. Now, there's a limit to this, 35 hours down here. So if I'm taking all these times 25, I take the 35 times 25. 875. So So the domain is from 0 to 35, and the range is from 0 to 875. Now, we got to ask ourselves if it's continuous or discrete. So I'm going to put a 2.5 there. You can work 2.5 hours. That makes sense. So it's continuous. Okay. So those are the two answers. Three answers. Domain, range, continuous. Okay. I'm going to go through another round. I'm going to scroll down on the document, and I'm going to redo it. Example 1. Write an equation for the table. Okay, P and S. We have the number of photos, which is identified by P, and then subscribers, which is identified by the variable S. So 0, 1, 2, 3, 512, 509, 506, 503. Okay, S equals, it starts at 512, then it's minusing, okay? Then blank P, you gotta have the P variable there. So let's start over here. 503 minus 506 is 3, but just put 3 though, okay? That's a difference of 3, that's a difference of 3, so 3 is the numerator. Then every time here's a difference of 1, so it's 3 over 1. Now 3 divided by 1 is 3, so S equals 512 minus 3 times P. Okay. Tell whether the function is linear or nonlinear. 0, 1, 2, 3, this is example 2. And then 1, 4, 16, 64. I mean, 64 minus 16 is 48. 16 minus 4 is 12, so that's nonlinear. I mean, that's obvious. There's a pattern, but it's not a linear pattern. Example 3. So XY table, 0, 1, 2, 3, negative 1, 2, 5, 6. So that's 1, 5 minus, okay, right away that's different right there. Or no, hold on a second. That's an 8, my bad, I'm sorry. 8 minus 5 is 3, 5 minus 2 is 3, 2 minus negative 1 is at 3. Yep, it's a difference of 3. Okay, and then that's linear. Okay, example 4, we have to graph the function 4x minus 5. Okay, so this is example 4. Go on graph paper and write y equals 4x minus 5. So I make my xy table, and the inputs are negative 2 to 2. So 4 times x minus 5, that's what y equals. So negative 2, negative 1, 0, 1, 2. So I just put those over x. So 4 times negative 2 is negative 8, and then I minus 5, it's going to be negative 13. 4 times negative 1 is negative 4, minus 5 is negative 9. 4 times 0 is 0, take away 5 is negative 9. 4 times 1 is 4, take away 5 is negative 1. 4 times 2 is 8, take away 5 is 3. So my x-axis, I just need 1, 2, negative 1, negative 2. Now, if you look at your y's, you have to get down to negative 13. That's the most extreme. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I run out of room. So negative 2, I number up by 2's then. Stop at 14. Now you do have a positive 3, so we want to go up, so we'll hit positive 3. So negative 2, negative 13. Negative 2, negative 13. -1, -9, -1, -9 is between the -10 and -12. 0, 5, it's between the 0 right there. Wait a second, I got -9 wrong. That should be up here. Okay. 1, -1, so 1, -1's there. Then 2, 3, so 2, and then 3 is there. And we have a line, okay, such as it is. Okay, 5 and 6, you need to look at the graphs, you know the vertical line test. Right here, I can go through 3 points at the same time, so that's not a function. Because all those have the same x coordinate, therefore the domain repeats itself 3 times, okay? But here, no, 1, 1, 1, 1, 1, 1, 1, 1, so function. Okay, then I'm going to go back to my notebook. Identify the domain and range of each relation. Then tell whether it's a function. That's example 7. So we have the coordinate pair 0 with 2, then the coordinate 3 with 1, then the coordinate 3 with -1, then the coordinate 5 with 3. So domain range, domain 0, 3, 3, 5. Range 2, 1, -1, 3. Okay, that's my domain and range, but since there's repeat 3's in the domain, it's not a function. Okay, example 8. Okay, same thing. -4, 4, -1, -4, 0, -4, 3, -4. So the domain and the range. Domain -4, -1, 0, 3. Range 4, -4, -4, -4. Actually, they're all -4s. Okay, you don't have repeats in the domain. You do in the range, but that don't matter. Okay, as long as you don't have any repeats in the domain, it's a function. Okay, example 9. Okay, the height of a helicopter is 40 feet above the ground. The height of the helicopter increases at a rate of 21 feet per second. Write a function rule for the situation. So h is the dependent variable. It starts at 40, then it increases, so add 21, but that's every second, so it's times s. Okay, and the last one, example 10. Peanuts cost $6 per pound. You have $42 to spend. What's the domain and range of the situation? Is the graph continuous or discrete? So domain, range. And then we have to ask ourselves that question, continuous or discrete. Okay, so what do we have? Well, XY table, it's going to be money is always Y, and then pounds is X. 0, 1, 2, 3. Alright, so if you buy 0 pounds, you don't pay anything. But if you buy 1 pound, you pay $6. So that's 6. 2 pounds, 2 times 6 is 12. 3 times 6 is 18. Okay, then the pattern continues, and we end up with $42 for our limit. So we got whatever this is has to be times by 6. Just you should put a times 6 there. So what times 6 is 42? Well, we need to divide 42 by 6. Some number times 6 is 42. So 42 divided by 6 is 7. So I put 7. Now is 7 times 6 truly 42? Yep, so I can leave it. So the domain is 0 to 7, 0 to 42. is the range. Now I'm going to put 2.5. Can you buy 2.5 pounds of something? Yeah, as long as it doesn't come in a container, you can. Okay, so that is continuous.